Section 8.3, Solving Inequalities Using Multiplication and Division. This is Day 1, Part 1.
So now you're on the back of your notes. We finished Case 1 using multiplication and division. Now on the back of your notes, we're going to do Case 2 here. And you probably could see it coming. What about something negative? So that's what Case 2 is all about. So in words it says, if you multiply or divide each side of the inequality by the same, here we go, negative number, what do we have to do? We have to change the direction of the sign, or the direction of the inequality symbol must be reversed for the inequality to remain true. So this is the same numbers we used on the front. So let's look at that. When I multiplied it, I think it was by 4 on the first video. When I multiplied both sides by 4, it turned out that I was multiplying by a positive number. Therefore, the simplified inequality actually turned out to be true. It was negative 24 is less than 32. And we said when we multiply by a positive number, it's true. But what happens if that number was negative? So let's change that 4 to a negative 4 here and see if the inequality remains true now. So a negative 4 times a negative 6 is a positive 24 now. And a negative 4 times an 8 is a negative 32 now. Now once I multiply by a negative number, does this inequality remain true? That negative 32 is greater than 24. And it's not. Or you could read it the other way. 24 is less than negative 32. That's a false statement. So just because I multiplied by a negative number, it made a true statement become false. So how do I change that false statement to make it true? What happens when we multiply by negative numbers? And in words, it says the direction of your inequality symbol must be reversed so that the inequality still is true after multiplying by a negative number. So when I multiply both sides by a negative number, I should have, following the rules of Case 2, should have reversed the direction of the sign, because I'm multiplying both sides of the inequality by a negative number. If I had done that correctly, now do you see that when multiplying by a negative number, that the inequality does remain true now, because I flipped it. 24 is greater than negative 32, and now that's a true statement. So overall, in Case 2, when you multiply or divide, remember it works for both, multiply or divide by a negative number, you need to reverse the direction of the sign. This only happens when you're multiplying or dividing by a negative number. So let's take that idea of when we're multiplying to reverse the direction and change it into algebra now, using a letter of the alphabet. So now I have a negative 4x is greater than negative 12. So now that coefficient is negative, and I need to remember with inequalities and dividing or multiplying by negative numbers, I need to reverse the direction of the sign. So when I set this up and I divide both sides by negative 4, it should be a red flag in my brain. I should be thinking something's up because I'm dividing by a negative number. And when I do that, I need to automatically reverse the direction of the sign. If this is saying that the left is greater than the right, then I need to flip it. In the end, once I simplify, the right is going to be greater than the left. So you're going to have to remember to do that. Negative 4x divided by negative 4 leaves me a positive 1x. Or we just write x, is less than now. So the left side is now less since I'm dividing by a negative number. And negative 12 divided by negative 4 is positive 3. We have to graph that. So when we graph that inequality, and we have 3 here, I'll just count by ones real quick. So when I place my boundary point on here, x is less than negative 3. So that means all the numbers that are less than negative 3 are part of my solution sets. And if I check, let's just throw 1 in here. So if I check to see if 1 is part of my solution set, when I substitute that in and simplify, it should be a true statement. Negative 4 times 1 is negative 4, which is greater than negative 12. Since since 1 made the inequality true, then that means that 1 should be in my shaded region, and I shaded it in. If you forget to reverse the direction of the sign, you will be shading the incorrect section of the number line. So it's always good to just take one of the solutions in your shaded region, plug, and check. So if you just say, okay, 1's in there, so I'm going to substitute that in, and I'm going to check to make sure it's true, because then it reminded you that you did remember to reverse the direction of the sign. If I didn't remember to reverse the direction of the sign, because I didn't remember about the negative, I would have shaded to the right. And what would that have done? If I had chosen 5 to throw in here, just to check to see if my solution set is correctly shaded, if I plug 5 in here, I get negative 20 is greater than negative 12. And that's a false statement. So that tells me that 5 should not be in my shaded region. That should give you a clue, a way to check, to say, oh, I forgot to reverse the direction of the sign because I did shade a negative number. Therefore, the true solutions are to the left of the boundary point. So there's a lot of things that we need to remember, but checking your work can always help you go back and identify where the incorrect thought or incorrect procedure happened. So right now, I'm going to jump to part C to show you that before your checkpoint, and we're going to do multiplication. So I have x divided by negative 3 is greater than 2. Since x is being divided by a negative 3, the inverse operation is to multiply both sides by the coefficient. So I'm going to multiply both sides by negative 3. But the minute I say I'm multiplying both sides of an inequality by a negative number, I need to remember to reverse the direction of the sign. Negative 3x divided by negative 3 leaves me a single x. Reverse the direction since we're multiplying by a negative number. And negative 3 times 2 is negative 6. So all the solutions that will make the original inequality true are less than negative 6. So quick number line check here, negative 6. This one I'm going to put 0 here, therefore I counted by 3's. So therefore this would be negative 9 and this would be negative 12. So there's my number line set up. And I'm going to place my boundary point and shade. So I'm shading to the left since all the values are less than negative 6. I'm just going to choose a quick number, negative 12. I'm going to plug that into my original inequality just to check to make sure I shaded the correct region. Negative 12 divided by negative 3 is 4, and it's greater than 2. So since 4 is greater than 2, and negative 12 did make the original inequality true, that means negative 12 should be in my shaded region. And if I look real quick, I shaded correctly because I did remember to reverse the direction of the sign. So you always just want to choose one value in that shaded region, plug it into the original equation, and check to make sure that you're shading the correct region. It's easy to go the wrong way. So we need to just have clues and strategies to get ourselves out of it. So I'm going to show you the checkpoint in the next one that you're going to do.